Hello and welcome to the GEM Tutoring Center's second video on Logarithms and Exponents Practice Problems. So this is video part 2. In this video we'll be talking about the several different problems, 3 different problems, especially about annual rates of increase and decrease and things like that. So let's start with the first problem. The price of an art piece 7 years ago was $100. Today it costs $450. To the nearest percent, what has been the annual rate of increase of the cost? So the function that we're going to use is this. We have v of t, it's a very thick brush, v of t is equal to v naught, a bit smaller, v naught 1 plus r to the t. Okay? So you may have seen this equation in your classes, but if you haven't, let's just quickly explain what it is. So this is the value over time, in this case the value of the art piece, and this is the initial value of the art piece. This is the annual rate of increase of the art piece, and this is the time in years. Okay? So, and the reason why this is called, this v naught for v0 is called the initial value is this. When you plug in 0 for t in this equation, you get v0 times 1 plus r to the 0. And we know that anything to the 0th power is 1, so that's equal to v0 times 1, or just v0. So at time t equals 0, v is v0, right? v of t is equal to v0. So let's use what we know about this to solve a problem. Let's quickly remind ourselves of what was going on. The price of an art piece was 7 years ago was $100. Today it costs $450. To the nearest percent, what has been the annual rate of increase of the cost? Okay, so let's write a function starting 7 years ago. Okay, so t equals 0 is 7 years ago. Let's start it like that. And let's change this to blue. Here we go. So v of t, oh my goodness. Okay, v of t is equal to v0 times 1 plus r to the t. Okay, 7 years ago, what was the price? It was $100. So that means v of 0 is equal to $100. And we know that v of 0 from up here, v of 0 is equal to v0. So this is v0. Okay, we could verify it like this. V of 0 equals v0 times 1 plus r to the 0, which equals v0. And because v0 equals 100, v of 0 equals 100, v sub 0 must also equal 100. So what that means is that our function is now 100 times 1 plus r to the t. And we need to find this r. Okay? So 7 years later, okay, 7 years later, the art piece is worth $450. Okay? And that is, when we write the expression for it, it's this, right? So we plugged in 7 here, and we got this, but it's equal to $450 7 years later. So what we're going to do is divide this 100 to the other side. We'll get 450 over 100. That's equal to 4.5, okay, which is equal to 1 plus r to the 7th. So in this case, now we have this equation. We're going to multiply both sides to the exponent of 1/7. So here's what that will look like. 4.5 to the 1/7 equals 1 plus r to the 7th, that to the 1/7. And the reason why we do this is because we want to get rid of this exponent above the 1 plus r. So that's going to be equal to 4.5 to the 1/7 equals 1 plus r to the 1, right? Because 1/7 times 7 is 1. That's equal to 1 plus r. Now let's move this 1 to the other side. We get 4.5 to the 1/7 minus 1 equals r. And it turns out that this r is equal to 0.2396, which is about 0.24. Okay, so r is approximately 24%. Okay, because it's an increase, r is positive, so it's greater than 0. If it was an annual rate of decrease, r would be less than 0. Okay, let's go to the next problem. Number 2. Okay, so it says here, the value of a box of paper, like the kind you'd buy at office store or something, increases by 5% per year. If the box of paper right now is worth $50, find its worth 3 years from now, 2 years from now, 2 years ago, and 1 year from now. So let's do that. Okay. We're using the same function as we had before. Let's do part A. The same function, which is v of t equals v sub 0 times 1 plus r to the t. Okay? So what they're telling us here is r. This is r, the annual rate of increase, or annual rate of change. And this is v naught, because this is the value currently, right now, at v of 0. V of 0 equals v sub 0, which equals $50. Okay? And r, they tell us, is equal to 5%, which is equal to 0.05. Okay? So we can put that into our equation. V of t is equal to 50, 1 plus 0.05 to the t. We can also simplify that and say v of t equals 50 times 1.05 to the t. Now they're asking us, find its worth 3 years from now. So v of t represents the box of paper's worth. So 3 years from now, so for t equals 3, this is for t equals 3, this is for t equals negative 2, and this is equal to t equals 1. So we'll talk about the negative 2 in a bit, but right now I'm just writing down the values of t for each of these sections. But we're doing part A though. So t equals 3. So let's plug in t equals 3 and see what we get. V of 3 equals 50 times 1.05 to the 3, okay? And what we get for that is $57.88. That's how much it's worth 3 years from now. Okay? Let's do part B. We're asking for 2 years ago. So the reason why we put negative 2 here is that this happened 2 years prior to the time that we're looking at now. The time we're looking at now is t equals 0. So t equals 0 is now. 2 years ago is t equals negative 2. Okay? So let's plug that in. V of negative 2, that's equal to 50 times 1.05 to the negative 2. Okay? And that equals 45, let me make it nicer, $45.35. That's 2 years ago. Okay? 2 years ago. Now let's do part C, which is 1 year from now. In other words, t equals 1. So what that's going to look like is this. V of 1 equals 50 times 1.05 to the 1, and that's equal to $52.50. Okay? That's 1 year from now. Okay? And here's another way that you can do the one year from now problem, part C. Because this, remember that this is the annual rate of change, this 0.05. okay, is 0.05. So what that means is that in 1 year, the value is going to increase by 5%. So if the value is 50, you take 5% of 50 and you add it to 50. So what is 5% of 50? Well, 10% of 50, here's another way to solve the problem. 10% of 50 is 5, right? You just divide 5 by 10. So 5% of 50, 5% of 50 is half that, which is 2.5. So 1.05 times 50, which is v of 1, right, is equal to just 50 plus 2.5, which equals 52.5. Okay? So let's go to the next problem. We're going through these kind of fast, but we want to get to as many as we can. Okay? The value in dollars of a baseball card t years from now is v of t equals 400 times 1.10 to the t. So part A says, what is the annual rate of appreciation? And B says, in how many years will the value of the card be approximately double what it is now? Okay, so the first thing we need to do is find the annual rate of appreciation. That means the annual rate of change that is an increase. In other words, r is greater than 0. That's what they're telling us here. R is greater than 0. Okay, so let's solve for the annual rate of appreciation. Okay, part A. So what we would do is we actually know what the annual rate of appreciation is, and I'll show you why, or how we know that. So this is the formula. What we see up there is the formula v of t equals v0 times 1 plus r to the t, right? So what they have told us is they've told us what v0 is. That's 400. That's great. We know that. But then they gave us this number here. So this is equal to 1 plus r. So this 1 plus r is equal to 1.10. So we can actually find r from here. When they say what is the annual rate of appreciation, they're asking for us to find what r is. So let's just do this very simple calculation. 1 plus r equals 1.10. So r equals 1.10, or 10%. The annual rate of increase is just 10%. That's it. That's all we needed to do. The next question is a little bit more involved. It says, in how many years will the value of the card be approximately double what it is now? Okay, so here's how we would do that. So it's double what it is now. So what is it now? V of 0 is equal to 400 times 1.10 to the 0, which equals 400. So right now it's 400. They're telling us in how many years, in other words, find t, when the value of the card will be approximately double what it is now. So double what it is now is 800, right? That's equal to some v of t, which we don't know what the t is. And that's, when we look back at the formula, it was 400 times 1.10 to the t. Okay? So we need to find this t. We need to find that t. Okay? So the first thing we can do is move this to the other side. So we get 800 over 400, that's equal to 2, okay, is equal to 1.10 to the t. So what we're going to do is take ln of both sides, or log of both sides, but I prefer ln. If you take ln or log, it gives you the same thing, as long as you do the same one on both sides, okay? So let's take ln of both sides. So ln of 2 is equal to ln of 1.10 to the t. And by the laws of logarithms, that's ln2 on the left side and t ln 1.10 on the left. Make that better, 1.10. Okay, that's a period right there. That's a decimal. Okay, and now we just move this to the other side. So ln of 2 over ln of 1.10 is equal to t, and that is approximately 7.27 years. So the baseball card will double in value from $400 to $800 in about 7¼ years. Okay, so that's the end of this video, and be sure to keep an eye out for the next one, which is Logarithms and Exponents Practice Part 3, where we'll be talking about some more logarithm problems. Please make sure to subscribe if you're interested in learning about when we have more videos, and please stay tuned.